The word solution comes up quite often on the SAT, and it can be a little confusing. We're used to thinking of solutions as answers, but again, solutions can be tested in different ways. For example, when an equation is set equal to 0, we're looking for the value that would make your function or expressions equal to 0. However, we could also be asked about the number of solutions, or we could be asked about what value would make something have a certain number of solutions. So we can always think of solutions in terms of functions, and both sides of an equation could be two separate equations. So let's think about how this could possibly work with a couple of examples. So we can solve equations if we're being asked for the direct solution. What is the positive solution to the given equation? So we could think of this as the intersection between the graph of y equals x plus 3, the absolute value of x plus 3, and the graph y equals 6. So for absolute value, we could just type in ABS, and then that would be x plus 3. So y equals the absolute value of x plus 3, and that's our graph over there. And then we have y equals 6. So that's the line. And it wanted the positive solution, so we look for the positive solution, which is 3 comma 6, and we were being asked for x, right? So x is going to be 3. Now we could do this with a square root over here, 5 times the square root of 3x minus 2. So that's 5 times the square root, so we just type in SQRT, and that was 3x and plus our minus 2. And we want it to be equal to 13. So that's y equals 13. And then we get a y equals over here. And there are our two functions. So now we just need to zoom out until we can see the two graphs intersecting somewhere, and there it is. And that is at the point 3 comma 13. So the value of x is going to be 3. The value of 3x would simply be 9. And over here, what is the value of h? So again, we can just throw x in for h and treat this as a system of equations, right? Because when two equations are equal to each other, that's where they intersect. So if we have 2.1 times h plus 3, so let's do 2.1 x plus 3. And then on the other side, we have 3x plus 2.1, 3x plus 2.1, right? And that gives us a intersection at 4.667, which is 4 2/3, or you could just type it in as the decimal, 4.666 or 4.667. Now we could also be tested on the number of solutions. So how many solutions does something have? Well, again, solutions are the points of intersections. So what we can do is simply just throw these into Desmos and figure out how many times they intersect. So over here we have 4 parentheses x minus 2. So that's 4 parentheses x minus 2. And then we got negative 2 parentheses x plus 4. Negative 2 parentheses x plus 4. So that has one intersection, which means it has one solution. Over here, which equation has no solution? So what we could do over here is just type that first half in because it's consistent among all of them. 4 parentheses x plus 1. And then figure out which one will have no solution, right? So no solution means it doesn't intersect at all. So the first one is x plus 4. That definitely intersects. The second one is x plus 1. That intersects. And then we have 4x plus 4. So let's try that. 4x plus 4. 4x plus 4 over here. And that's actually the exact same line. So that would be considered infinitely many solutions. And by now we know the answer choice has to be D, but we can visualize it, just 4x. And notice these are parallel lines. We could zoom out forever, and they would still never intersect. And we could also just be asked for how many solutions something like this has. And again, we saw this in this question over here, right? Notice that the lines that we had in the previous question were parallel. Parallel lines have the same slope and different y-intercepts. So over here, we have the same slope and different y-intercepts. That's going to be 0 solutions. But if we wanted to be sure, we could do 4x plus 1. Just edit that up. And 4x plus 3. Same idea over here. Those are parallel lines, so no intersections. They do not intersect. They have no solutions. 0. And then we could also play around with different values, different constants that could make things have a certain number of solutions. And this is commonly tested in quadratics these days as well, right? Which value of a will make the quadratic function have no solution. More on that when we get to the quadratics lesson, but keeping it simple and linear, the given equation b is a constant if it has infinitely many solutions, which means it's going to be the same exact function. So we could just type in our function over here, 4x plus b, and then divided by, and that's going to be 2. And we're going to add that slider for b to play around with the different values of b. Then we have 2x plus 8. 2x plus 8. So again, we want these two lines to be overlapping each other. That would be infinitely many solution. So our first value of b could be 2, and then the next one's 4. So 2, those don't overlap. 4, those don't overlap either. Then we got 8 and 16. 8, nope, 16. And there we go. Those overlap. We don't see another line over there. So our answer is just going to be 16.